Hey there, kiddos. We talked briefly about the three ways to prove that triangles are congruent. And there are a couple more, but for now, recall that there are three ways to prove two triangles to be congruent. And I'll write those out on the side. So remember, we have side, 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 and angle, side, angle. Right, so those are the three ways we can, for now, prove two triangles to be congruent. So in this particular video, I just want to introduce you to how a proof that would use one of those three ideas for now may feel and look. Okay, and tomorrow we will start to investigate more what these proofs look like, and you'll start to write some. So that said, here's a particular problem. We have this diagram, and we know that FG, and I'm going to mark it up right here, is congruent to FI. So I'm going to mark that up. Okay, and we also know that FH. So here's FH right here, right? So FH right here bisects angle GFI. Now remember what angle bisectors do, right? So that means by definition of bisector, those two angles are congruent. Okay, and what's neat here is that both triangles contain this FH. Okay, so if we were to split these two triangles apart, right here, oops, what is this? What's going on? Sorry, here is triangle FGH, right? And here's that shared side right there. Right, and here is triangle FHI, and that's that shared side right there. Okay? And so what we're trying to do is to prove those triangles are congruent, right? That's our goal. Right? And so I'm going to mark these two separate triangles up. There's angle 1, there's angle 2. And those two sides are congruent to themselves. Okay? So the first thing I want to decide is what technique I'm going to use to show those two triangles are congruent. Okay? And for this particular one, I'm going to use side, angle, side. Okay? Sides, right here. FI is congruent to FG. Included angle, by the definition of an angle bisector, angles 1 and 2. And then by the reflexive property, FH is congruent to FH. Okay? So as we discussed in class, those two triangles can be shown to be congruent by side, angle, side. Okay? So here's what the proof is going to look like. Okay? What I'm going to do is, before I use side, angle, side, I have to show that we have two pairs of congruent sides and a pair of included congruent angles. So I have to establish that first. So I'm going to use side, angle, side. I'm going to erase the other two because I don't need them. So here's how my proof looks. Okay? I first have to begin by establishing sides are congruent, angles are congruent, sides are congruent, right? And then that would mean by side, angle, side, the triangles are congruent. That's where I want to end up. Okay? So I'm going to first start with the first pair of congruent sides. And that's from the given, right? So I'm just going to say note FG is congruent to FI. And that's just given, right? So I don't really have to justify that. And that's one pair of congruent sides. All right? And I'm also going to note that FH bisects angle GFI. Okay? Now, that in and of itself isn't that interesting. However, what follows from that is that, therefore, by definition of an angle bisector, doesn't that make angle 1 equal or congruent to angle 2? Okay? Now, note here how, I just established a pair of congruent angles, right? So for your side, angle, side relationship, I have a pair of congruent sides, and I just established the included pair of congruent angles, right? Also note how I justified by definition of a bisector, right? Angle 1 and 2 are congruent. Okay? The second pair of sides comes from FH, right? Both triangles share the same side. So I'm going to say further, that's by the reflexive property, right? Anything is equal or congruent to itself. I can say that FH, which is part of both triangles, is equal to FH, or congruent to FH. Oops, not FG. That should be an FH. All right, this side right here, FH, is in both triangles, right? It's a shared side, and so it's got to be congruent to itself, right? And that's my second pair of sides, right? So far in my proof, I've established congruent side, the included congruent angle, and the other pair of congruent sides. Okay, which means now I'm ready to say, therefore, by side angle side, the whole triangles are congruent. So triangle, and I need to write it in the appropriate order so that corresponding pieces match up. Triangle FGH is congruent to triangle FIH. Okay. So this is your first taste of a triangle congruency proof. I did want to introduce this to you tonight through just one example, and I want you to think about it. Okay. Note how I established sides, angles, included angles, sides, right? Which on the diagram are sides, included angles, sides, right? Or sides, if you split them up, included angles, sides, right? So I first established that those two triangles have the same, what we call side angle side relationship. And then, bam, therefore, by side angle side, the triangles themselves have to be congruent. Okay? So, we're going to pick up with more of these tomorrow. Thanks for listening. Come in with questions. I'll do one more tomorrow at the beginning of class, and then you guys will start to write some tomorrow after I do one. Have a great night. Take care.